In order to demonstrate the working of the executor service, I have already created this package, that is the executor service, and now we will learn about the single thread executor. So let's create a class. Let's call this as single executor demo. We will have a class. Let's call this as task, and it's going to implement a runnable, and it will have a task ID. So let's call this as task ID. Let's have the constructor. Let's override the run method. And in the run method, we will print a message task with ID, task ID being executed by thread, and then thread dot current thread dot get name, and let's put some sleep in the thread. Let's have it for half second, and in the catch handle the interrupted exception. So we will just throw the exception for now. Let's call this as a runtime exception and pass the exception here. Here we will create the main method, and in the main method what we will do is we will create the single thread executor now. So in order to create it, we have the executors dot new single thread executor, and let's assign this to service. Now the IDE is complaining and showing some warning message. Let's see what does it say. It says that executor service used without try with resources statement. So the executor service should be closed once we are done using it. There is a way in which we could close it, and that is by calling the service.shutdown. But there is a different approach as well in which we can implement the same, and that is to use the try with resources. So let's do this and put it under the try with resources, and now we should be good to go. So let's say I want to run this task 5 times. So for int I as 0, I less than 5, I plus plus, and I can say service dot and then call the execute. So what is the runnable that I want to execute? That is my task, and pass I as the task ID. So as opposed to what we were doing earlier, that after creating the thread we used to call the dot start in order for the thread to get started with its operation. Here we don't need to do it. Rather, once we submit this to the executor service by calling .execute, it is handled by the executor service itself. Now let's run this code and see what is the output like. So let's run this. So here is the output. So basically it's going to print task ID with 0 being executed by this particular thread, and task ID with 1 being executed by this particular thread, and so on so forth. So this is what we have implemented in the code as well, right? The idea is that there is a runnable, and what it does is it's simply going to print the task ID along with the thread by which it is getting executed. So if we had not used the executor service, what we would have done is we could have created 5 threads, and using those 5 threads I could have assigned the runnable for each of the thread and then should have called the dot start on that. But here we are able to achieve the same kind of result using the executor service and this implementation in particular, which is new single thread executor. So now the implementation looks much more cleaner, and we don't have to deal with the creation and destruction of the threads. Now everything is being handled by the executor service itself. Let's learn how the single thread executor works under the hood. So we have the main thread, and this way we can create in tasks and submit or execute those tasks one by one. So here we have the thread pool, and in the thread pool there is a single thread. There is a task queue which is containing task 0, task 1, task 2 up to task n. And what this single thread executor will do is it will pick the task from the task pool or the task queue and then execute it. So fetch task and execute. So in the case of single thread executor, the size of the thread pool is just 1. So we have just one thread which is going to fetch the tasks from the task queue and run this. And if it so happens that due to some exception the thread is killed, the executor will make sure to recreate the thread and the execution of the tasks won't be stopped. By using this kind of thread pool, we can ensure that the task 0 is always ran before task 1 and task 1 is always ran before task 2. Since we have just one thread here, it's guaranteed that the tasks would be ran sequentially